240 trees, sorted and stacked into one honest staircase per treatment. No bins, no smoothing, no argument about bar width. Each step is one real tree. The height is the fraction of the orchard at or below that yield. Watch biochar closely. It climbs early and gently because 44% of its trees sit under 55 kilograms. A tail no bar chart would have shown you. A histogram forces a choice you shouldn't have to make. How wide is a bin? Pick wrong and you invent bumps that aren't real or erase ones that are. The ECDF sidesteps the whole argument. Sort the data, count the rank, plot the fraction. Every single tree gets its own step, and the curve reads the same no matter how you squint at it. It's the most honest shape a dataset can wear. Here's what each staircase is built from. 40 control trees, 62 compost, 59 biochar, 79 mixed. Slide the dashed line across the yield axis and watch each curve's height change. That height is the exact fraction of trees at or below the line, no rounding to a bar. At 55 kilograms, biochar reads 44%, while compost reads just 16, despite medians only 3 kilograms apart. 4 lines build the whole chart. Sort the yields with numpy so the smallest tree comes first. Build the rank 1 through n divided by n so the curve always tops out at exactly 1. Step through the sorted values with where equals post. That's Matplotlib's convention for a right continuous ECDF. No bins argument, no smoothing kernel, just the data in order. Watch the tree count alone. 6 trees gives you 6 giant steps, barely a shape, and you couldn't trust a single percentile off it. 30 starts to resemble a curve. Bring back all 62 compost trees though, and the staircase turns fine-grained enough to read any fraction with confidence. There's no bin width to tune here. More data just means a truer curve, point by point. This argument decides where each jump sits. Set where to pre and a tree's value counts before it actually happens. The curve lies about when the jump occurred. Set it to mid, and the step splits the difference. Smoother to look at, but statistically wrong. Post is the honest choice though. The jump happens exactly at the data point and holds until the next one. That's the real definition of a cumulative distribution. 5 bins on biochar's histogram looks tidy, but it quietly averages away the exact fact that 44% of biochar's trees yield under 55 kilograms. You just see one tall bar and guess at the rest. Switch to the ECDF on the same trees though, and that number reads straight off the curve's height. No bin width to pick, no guessing. The staircase never hides what the histogram bar just smoothed over. Now you drive, on the mixed treatment this time. 10 trees gives you a handful of clunky steps, barely a shape. 25 starts to resemble a curve. 50 gets close to trustworthy. All 79, and the staircase is fine enough to read any percentile with confidence. There's still no bin count to argue over. The only knob that matters here is how much real data you feed the curve. All 4 curves at once is honest, but busy. Pull out just compost and biochar though, and the real story jumps forward. Compost's staircase climbs like a cliff around 60 kilograms, tight and predictable. Biochar's climbs like a gentle ramp from 29 kilograms all the way to 85. Same rough median, utterly different risk. Isolating the pair makes that gap impossible to miss.